Hello, thank you very much for letting me speak to your customer base. I'm Erwin Argyle, and I work at Siemens, and I'm the product manager for Geolus Shape Search. And so that's what we're going to be talking about today. In front of you, you'll see our agenda, and always we're hoping to help you solve a particular problem. And then I'll let you read the rest of the agenda just for a second or two, and then we'll get started. So driving business with Shape Search, how do we do that? What are we doing? We're overcoming the limitations of traditional search. And so what is the problem then that we're trying to solve? In a word or two words, it's part proliferation. Today, it's so many companies are making parts so easily, and they don't use what they've already made because they can't find it. And so the impact of that, of course, is part proliferation, but it's not limited just to the design engineering use case, which is where you've got maybe teams of engineers working in silos, making the same part over and over again. It extends to other areas as well. And so even in procurement, where we might find that there are more suppliers than we might need to work with, or that we're buying the same item from different suppliers, or even the same item at different prices. And another example of part proliferation is when you're trying to consolidate after a merger and acquisition. And so the question then is, what does this do for us? Or what does this do to us, rather? And so when reinvention is the norm, what we're doing is killing any chance of standardizing, and then we're also increasing the complexity of our inventory. So basically, it's become easier to create a new part than it is to find an existing one and reuse it. Most people would agree that it makes sense to make use of work that you've done before. No one likes to work twice. But the problem is that parts have to be found before they can be reused. And traditional search is based on keyword. And so if the parts are named inconsistently, and this is notorious in virtually all engineering practices, then we're going to not be able to use traditional search to find our parts. And so, as I said before, if we've got teams of engineers working in silos, then no one really knows what the names of the new parts that are being created, yet they're solving the same problem over and over again. And in fact, if you were to, again, in a nutshell, summarize this problem of the multiple naming, it's having multiple cultures under one roof. And so you can imagine that it actually is potentially even worse with procurement, because each supplier has its own way of naming items, and those have to be under the one roof of the customer, as without using the procurement's or the supplier's names, then you won't be able to have a conversation. And so this is a very serious problem that's worth addressing. And if we were to look at the images on the screen and to get like a big 50,000 foot picture, here we can see that an engineer has started off with something that's very coarse. He could have created this with a rough sketch, or maybe from a collection of faces that make some kind of control design volume. And then with Shape Search, found a number of different items. And note that this is a very coarse search, which means that not every result is going to be great. But it's enough to ballpark the items that are likely. And then we're looking at the information about those parts. We can make sure that it's the right material, the right strength, that whole thing, and then look and see which parts have been found and then make use of it. And so what's happened then is that we've used search to find parts whose names we don't know. We've been able to reuse rather than reinvent. And if this happened repeatedly, then we can establish a best practice and maybe work out which would be a standard part to use, which would again, limit the complexity of our inventory and give us access to our history, as it were. And so what this means is that as we go to use a part, it's that decision that we make is an informed one. There's quite a lot of information about the cost of a part, what it costs to add a part to the inventory, not so much inside the private sector, but there is quite a lot of work that's been done this way by the US government. And so it is worthwhile doing some research and seeing just what those costs are, because it will surprise you. And if you're saying to yourself, well, that item is so simple, I may as well make a new one rather than look for an old one, then you're really not looking at the big picture, and that there are some significant savings that can be made. So search by shape. So you seen already an example a bit like this one, where we had a very coarse shape, and then we looked to find something that had been finished. But I could equally as easily have started with something that was finished and find other finished items that are like it. And so the quality of the match, or the control of the match, is literally a slider on most of the shape search clients that we have today. And so so that means we're sort of supporting both sides of that way of working. And it might be interesting to note that we consider shape and size to be independent controls. So these two items here have the same shape, but of course they're different sizes. And then the last item here, which is using metadata, to me, this is the difference between having a cool technology and a solution, in that there isn't really any point in finding, say, clips and fasteners and brackets if you're looking for aluminium, but you get given plastic. So it's important to be able to have access to the metadata. And in fact, it's even bigger than that. I think it's through the metadata that we get the ability to drive business. That is what I alluded to in the title. And in fact, when I'm asked what is the value of Shape Search, it's much, much bigger than just, oh, I've got this part, I can use this other part instead. If you think about it, the inventory of an engineering company is like a reflection of the investment that has been made over the years, in that every part has got a drawing, every part maybe has a price, has a way it was designed or a way it was manufactured, that there's maintenance, knowledge and issues, projects were used, and so on. And it's a vast reservoir of knowledge that is almost completely untapped, because there is no way to browse it. It's haphazard. In the UK, where I'm from, we have a saying, you can't see the wood for the trees. And that's definitely the case, where if you have a technical problem pertaining to 3D data and you'd like to get some answers, all of that information in your enterprise is so hard to navigate that you can't get the answer that you know is there. But if you look at the rest of this diagram here, by passing the shape search through and identifying those items that are similar, now when we step from the part to the drawing, or to the QA results, or to the manufacturing process, because this has now been sorted such that all of these items are similar, this data is now much more ordered. And so what this means is that you have a very nice collation of data that you could never otherwise have, because these parts are independently named. That's where the chaos is. But by grouping them together so that you've got this smaller, tighter group, you now have something that you'd be able to use to answer your next problem. And so it's not limited to design engineering use case, not limited to procurement. It's valid everywhere. And the screenshot on the right is a kind of embodiment of that, in that when I first did a search for an item like this one, about 200 parts were returned. I then applied some metadata filtering. This isn't sort of real engineering data, so I didn't have the vast experience to call on here. I quite simply said, well, find the ones which are owned by me, as opposed to the 10 or so other engineers I had in my demo set. And we found there were about 22 of those. And I could have used date or where used or the release status. Any of those kinds of things would have been useful or would have been available to be filtered on. And so then what happened, well, I got the 22 and then cherry picked the 5 other parts most likely to have the information I wanted, changed to a table view in Active Workspace, which is part of Team Center, and then changed the view to be tabulated. And so now I've gone from this chaotic arrangement of information to this very ordered arrangement of information pertaining to items shaped like this. And that's the value of Shape Search. It's much, much grander than just I could use one part instead of another. The way Geolus is architected is that the Geolus Shape Search engine is set up as a Java application, and I can answer more about that if there are questions. But essentially, the search client part of it can be embedded in almost any application, and then it connects to the Java search, the Geolus Shape Search engine through HTTP or HTTPS. And so what this means is that as you look at these things, here's NX, a solid edge, and this actually is a third-party design system. And here we've got 2 Team Center clients. Each user interface has its own look and feel, and so that means we're not forcing like an architecture that on the user, and that each of the developers can then produce the user experience that their users would know and expect. And over here, we've got a third-party partner called BCT, who are responsible for A-Class. They also have Shape Search in their product. And so we do make Geolus available on a level playing field to any software vendor. And this last interface here, the Geolus web interface, that's a bit like our direct access to Geolus for getting results. It's probably more useful or particular to, say, some small team reporting to head of engineering or the IT group who are setting Geolus up in the first place, because what this does is give you this direct access independent of Team Center, whereas all of these other applications, they require Team Center credentials, they follow Team Center security, and so you only see the results that you are permitted to see, and so on. So maybe a couple of examples, and you have to forgive me, I'm not the most experienced NX user, which means I know how to use one command in NX, and I'll sort of show you that now. And so if I bring over here NX, so I'm running live, it's connected with Team Center, and you can imagine that it didn't take very long for a CAD user to be able to produce this quick sketch. And inside this this NX, I've got a connection to Team Center, and so if I click over here, you'll see Active Workspace, and what I can do quite simply is select the model and then ask for a shape search. And so we'll then, it'll do its job and come back with some results. And so here you see it's found some, and it looks like it's found about 200. And so I'm going to expand the Active Workspace view so that we can then look at the results that have come through. And so this is all real time. There's a variety of parts in here. And as I scroll through, you might be saying to yourself, well, none of these look particularly like that very simple model I started off with. But the thing is, these are the closest matches to it. And so that means this is as simple as the sides and the base plates for this U bracket are. And as I scroll through, because Geolus returns the results in order of similarity, we're going to get less and less similar parts as we scroll down the results. And in fact, if we look down here now, you can see when we got to this point, the aspect ratio of the model was beginning to change a lot. This is quite a big base plate. And now when we go over here, you can see the geometry is a bit different because we've got, say, these 6 holes. And so it's getting further and away from the thing we started with. But just like with regular search inside Google, you often find that the first result you get isn't quite the one you want, and then you can plow those results back into the next search. And so let's say that I was actually looking for something with these 6 locating holes. What I could do is now I could select this item and note a couple of things to note. Where the scroll bar is in this search. This tells me I'm about halfway through a whole bunch of parts, and the scroll bar is small, suggesting that there's quite a few parts. What I could now do is another search based on the item that I had selected. If I do that now, what you'll see is we've gotten fewer parts because we now have selected a more complex model, and the scroll bar has gotten bigger. So I've got fewer results. And if what I wanted to do was look at the metadata that was associated with these parts, I could do that here. And so we can see that we've got a variety of owners, last modified users, dates, and like I said before, if this were more real, I'd have release status, maybe the classification information, all those kinds of things that I could use to better qualify these things. Then the last thing I'd show on this, in the interest of time, if I go back to the search filters, I think I mentioned that we had controls along the lines of the closeness of the shape, and then here's the closeness of the size. So if I drop this down to here so that I'm in the middle, so it's things which are smaller and things that are bigger. And if I were to drop the quality or tighten up the quality, I go from 198 items. And if I keep dropping down a bit further, it's going to 165 items. A bit further. Each time I'm doing this, I'm doing a new search. 125 items. I jump 2 notches over here, and I go all the way down to 61 items. So we now, and I can keep just going down until I look for things which are identical, and I know there isn't anything identical, so I won't bother. But this gives you an idea of the integration. And let's say then that this part over here, for example, looks like the one I want. I could then click on it, and it'll be fetched from Teamcenter and then put into my NX desktop, and there it is. And so if we were to look at the model, you could then see that you can then see how it was made. And so there's your finished part. All right. So, and so I'll show another example real quick. And this one I think is kind of interesting because it's using Shape Search as part of a workflow, the kind of thing that you might want to do. It's not just Shape Search per se. So this comes from BCT, our partner, who has embedded Geolus Shape Search inside their A-class product. A-class is like a layer over Teamcenter classification. And so this is the story of a company that's making small computers, and this is the backplate. I think you can see that there's a network port, maybe USBs, graphics, something else, and maybe power. And so that you've got there's a story here that this company is making these backplates. And so what they're going to do is they're convinced that they're making more back plates which are very similar than they need to have within their organization, and they would like to standardize. So the first thing they're going to do is, you see it says 3D search down there. They're going to do a search. They've got their own way of organizing it, and so it's a broad search though, and so as the results get less and less likely, then they cut it off and say, well, we only need the first 6. So what then happens is they're saying, well, of those first 6, it looks like they haven't all been classified. So what we can do is we can automate the classification of those 6, because we can replicate the classification on any one of those 6, and then so then we're classed. And what we can further do is then allow effectively management to have a say on what gets used on the shop floor, and so they're being color coded as being green for preferred or red for deprecated. And there's any number of reasons why you might deprecate. It could even be that because the credit history of the supplier is in question, and you don't know if they're going to be able to make ITAR compliant items in 5 years' time. We don't know, but the point is that we've given a chance to choose which are the right items that we want to become the standards within our company. And I don't have a video as such for the procurement, but two things I wanted to point out. The first one is that it's really important to always have like the big hat on when you're trying to understand what's the best you can do for your company, and then also how Shape Search can help. And I chose to put this diagram up because in the same way that in your typical design engineering use case, you've got things like the design, testing, documentation, work instructions, all sorts of things like that. There are that many steps with procurement as well. They're just different. And so it's valuable for both parties to be able to make use of Shape Search if they can. And if there's a savings to be made, that savings is big because the ripple effects of the downstream processes is eliminated. And so the picture here is that each time a purchase is made, a SKU is created and assigned. It's a bit small writing here, but in the light blue is the SKU that gets assigned each time a deal is made. And then the label in black is the supplier's name. You need that, otherwise you can't have a conversation with the supplier. But what's interesting is that when you see the supplier's name appear twice, that suggests that exactly the same item has been purchased, and we have not taken advantage of that to consolidate. And so you can imagine if whatever these items might have been, if production was stopped because the bin that contained this one was empty and nobody realized that around the corner there was another bin full of these where production could have continued, then that's the kind of thing that that is important to know. And of course, we could have worked this out just with a spreadsheet, because all we have to do is pattern match the designers' names, and then that would tell us how we can do better with documenting our purchases. But look at these other items as well. I've chosen these just because they're green, but the geometries, if I were to be tight enough, could be so similar that maybe they would be candidates for a similar consolidation. And so the idea then is that what Shape Search is bringing to the table is these other items for consideration if you wanted to understand what your purchase history was, look for how you would find a supplier that would give you the part that you want, and make sure that the prices that you pay are similar to the ones that you have been paying. And so this kind of information is very useful. And so remember, if you like, the procurement life cycle is quite different to the design engineering life cycle, yet Geolus is helpful to both. And my hope is that you would work out for yourself what the use cases where Geolus can help you. And then I think what I'm going to do is just skip to experiences of one of our customers. So JCB in the United Kingdom, they had a part proliferation issue. It's 12% per annum, 2010 to 2016. They couldn't successfully bring in classification. And the governance was really, when somebody wanted to bring a new part in, they would say, have you looked for another part that would work? And the answer would nearly always be, no, I did look, I didn't see it. And of course, engineering are always choosing the same items they always choose, not necessarily taking into account what the cost was and things like that. And with JCB, they're able to introduce what we call a geometric firewall. So part of the release process of a part would be to see if the part already existed before it was permitted to be released. And their growth is now down to close to 6% per annum, and that's saving them an enormous amount of money. And Geolus has the means to identify which items are similar, and so, as you saw in that movie, which classes should be shared. So it's been very helpful for them. And I think I'm going to stop now, and then if you have questions, then you're welcome. But where is Geolus valuable? I think the answer is everywhere. There's always going to be a diagram like this with many steps where if you can eliminate a part, you've saved all of those ripple costs.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.